Hi students, today we will be discussing the concept of continuity, right? When we can say that a function fx is continuous means it is not breaking, right? Now you can see this function right over here that fx is continuous in the interval a to b, right? This is not breaking anywhere, right? So this fx is continuous, right? Now for a function to be continuous, the limit should exist at that point, right? Now if I want to determine that if fx is continuous at the point c, so what I'll do, I'll at that point the limit should exist, right? And f of c should be equal to the right hand limit and the left hand limit, right? So that is known as the function will be continuous. Now if I say what are the example of continuous function, like say if I say e to the power x, right? So this is the graph of e to the power x. This is always continuous, right? From minus infinite to infinite, right? Now I say suppose what is the mod x. Now say this is the graph of y is equal to mod x, right? So now this function is also continuous over the range of minus infinite to infinite, right? These are some example of continuous function. Now we'll discuss about what are the discontinuity. So see, majorly three types of discontinuity is present in any type of function, right? So first we'll discuss the jump discontinuity, right? Jump discontinuity means suppose I have this kind of function, right? So this is the jump, right? So now this function is discontinuous and this type of continuity is known as jump type discontinuity. Now second is removable discontinuity, in which suppose I have some function like this and now there is a hole, right? So this is known as the removable discontinuity. Now this is discontinuous due to this hole, right? Now the next is infinite discontinuity. Suppose I have y is equal to 1 over x, right? How the graph of this will be look like this, right? At x is equal to 0, this fx will tends to infinity, right? So now at x is equal to 0, this graph is not continuous, right? So this at x is equal to 0, we can also say these are the vertical asymptote, right? So this is known as the infinite discontinuity. Now we'll solve one or two example on this concept, right? So now the first example, fx is equal to x square for x less than 0, right? And that is equal to x plus 3 for x greater than equal to 0. Now to determine the left hand limit, that fx for x tends to 0 minus, we have to use this function, right? Because this is we have to use for x less than 0. Now if we put x is equal to 0, this is equal to 0, right? Now for right hand limit, if I put fx x greater than 0 plus, I'll have to use this function, right? So this is 0 plus 3, this is equal to 3. Now we say that right hand limit is not equal to left hand limit, so this function is not continuous, right? At x is equal to 0. Now if we see the graph of this function, now see for x less than 0, this is x square, right? So this will be the x square, and now for x greater than 0, this is x plus 3. So now suppose this is 1, 2 and 3, right? So this will be the graph. Now we can see this is what kind of discontinuity, this is jump type discontinuity, right? That's why this graph is not continuous at x is equal to 0. Let's see the next problem. Now this is fx is equal to x square minus 1 for x less than 2. So first we'll find left hand limit. So if we put fx, x limit tends to 2 minus, if I put 2 square minus 1, so that is equal to 3, right? Now for fx, for right hand limit, I have to use this function, right? X 2 plus, that is equal to 4 into 2 minus 5, that is also equal to 3, right? And f of 2 is also equal to 3. So now at x is equal to 3, the limit exists, right? So we can say this function is continuous at x is equal to 2. Now this way you can determine that function will be continuous or continuous. You can also draw the graph of function to determine the continuity or discontinuity of function, right? I hope you were able to understand this topic. If you have any doubt, you can write them in the comment box and I'll try to answer your questions. Thank you.